Think of a spark plug, not just as an ignition device, but as a direct informant from the heart of your engine, the combustion chamber. Its condition, particularly the color and nature of any deposits on its firing end, provides invaluable insights into the complex processes. While a healthy engine running optimally typically leaves spark plugs with light tan or grayish deposits, the appearance of white deposits signals specific conditions that warrant immediate and thorough investigation. White deposits on a spark plug's insulator nose, electrodes, and sometimes even the metal shell can vary in appearance. They might look chalky or powdery, sometimes appearing more glazed or ash-like, especially under high temperature conditions. It's important to differentiate these from regular, healthy deposits. Normal deposits are typically light brown or gray, indicating balanced combustion. Conversely, black, sooty deposits usually point to a rich fuel mixture or weak ignition, while oily black deposits signal significant oil consumption. White deposits, however, often indicate excessive heat or the presence of foreign substances burning in the chamber. Several distinct engine conditions can lead to the formation of these telltale white deposits. Understanding each potential cause is key to accurate diagnosis. A lean fuel mixture is one of the most common culprits. A lean condition means there is too much air relative to fuel entering the combustion chamber, a high air-fuel ratio. This excess oxygen causes combustion temperatures to soar significantly above normal operating ranges. These elevated temperatures can bake fuel and trace oil contaminants onto the plug, resulting in white, often powdery or blistered deposits. Critically, lean running not only causes white deposits, but also drastically increases the risk of detonation and severe engine damage due to excessive heat, potentially melting pistons or burning valves. Electrode erosion on the spark plug itself is also accelerated. Overly advanced ignition timing. The ignition system dictates when the spark plug fires relative to the piston's position. If the timing is too far advanced, spark occurs too early in the compression stroke, peak cylinder pressures and temperatures rise dramatically. This increased thermal stress contributes directly to the formation of white deposits on the plug insulator and electrodes. Like lean conditions, overly advanced timing significantly increases the risk of damaging pre-ignition and detonation. Incorrect spark plug heat range, in this case too hot. Spark plugs are designed with specific heat ranges that dictate how quickly they transfer heat away from the firing tip into the cylinder head. A plug that is too hot for a specific engine application, meaning it retains too much heat and doesn't dissipate it effectively, will overheat. The insulator nose temperature exceeds its design limit, leading to the accumulation of white, often glazed or blistered deposits. Using the manufacturer-specified heat range is critical for plug longevity and preventing engine damage. Using fuel additives. While less common in many modern gasoline formulations due to regulations, certain additives, particularly octane boosters containing metallic compounds like MMT, methylcyclopentadienyl manganese tricarbonyl, can leave deposits. These deposits are often described as whitish, but can also present with reddish or brownish hues depending on the specific compound and concentration. While intended to improve fuel quality, overuse or certain formulations can lead to fouling. Minor oil consumption. While significant oil burning typically results in black oily fouling, small amounts of engine oil seeping past worn valve stem seals or piston rings can burn at high combustion temperatures, leaving behind hard, white or grayish-white ash deposits on the insulator and electrodes. These deposits are usually harder and more fused than those from lean mixtures. Coolant contamination. This is perhaps the most serious cause, an internal coolant leak often due to a failing head gasket, cracked cylinder head or cracked engine block allows coolant, ethylene glycol or propylene glycol, to enter the combustion chamber. When coolant burns, it leaves behind very distinctive white, chalky, sometimes fluffy or even slightly greenish-white deposits. Finding such deposits demands immediate attention, as coolant contamination can rapidly lead to catastrophic engine failure, including bearing damage due to contaminated oil, cylinder scoring, and severe overheating. General engine overheating. Any condition causing the engine to run significantly hotter than normal, for example faulty thermostat, radiator issues, cooling fan failure, elevates overall combustion chamber temperatures. This increased ambient heat within the cylinder contributes to higher spark plug tip temperatures, potentially promoting the formation of white deposits, even if other factors like air-fuel ratio and timing are correct. The presence of white deposits is more than just a cosmetic issue. It's a symptom of underlying problems with potentially severe consequences. Deposits can accumulate sufficiently to foul the plug, either by coating the insulator, preventing proper voltage buildup, or by bridging the gap between the center and ground electrodes, shorting the spark. The conditions causing white deposits, lean mixture, advanced timing, hot plug, general overheating, are often the same conditions that lead to uncontrolled combustion events like pre-ignition, ignition before the spark, and detonation, explosion of end gas. These can rapidly destroy pistons, rings, rods, and bearings. Fouled plugs or engines running under detrimental conditions, lean hot, will inevitably suffer from reduced power output and poorer fuel economy. Fouled plugs or engines running under detrimental conditions, lean hot, will inevitably suffer from reduced power output and poorer fuel economy. As highlighted, particularly with coolant leaks, extreme lean conditions or persistent detonation, failure to address the root cause can lead to catastrophic engine failure, requiring extensive and expensive repairs. When white deposits are observed, simply replacing the spark plugs is insufficient. A systematic diagnostic approach is required. Check long-term and short-term fuel trims. High positive trims indicate the engine control module is adding excessive fuel, strongly suggesting a lean condition, perhaps due to vacuum leaks, fuel delivery issues, or faulty sensors like the MAF or O2 sensor. Use a scan tool or timing light on older vehicles to confirm ignition timing is within the manufacturer's specifications under various operating conditions. Perform a cooling system pressure test to check for leaks. Examine the coolant reservoir for level drops and check the oil for a milky appearance, indicating coolant contamination. Monitor oil levels closely. Consider a cylinder leak down or compression test to assess ring and valve seal integrity if oil burning is suspected. Double-check that the installed spark plugs are the correct part number, and crucially, the correct heat range specified by the vehicle manufacturer for that specific engine. White deposits on spark plugs are a clear signal that something is amiss within the engine's combustion process. They are not the problem itself, but rather a crucial symptom pointing towards potentially damaging conditions like lean mixtures, excessive heat, incorrect timing, oil intrusion, or dangerous coolant leaks. Regular inspection of spark plugs as part of routine maintenance provides an invaluable opportunity for early detection. By understanding the causes and implications of white deposits and undertaking a thorough diagnostic process to identify and rectify the root cause, technicians and informed owners can prevent costly engine damage and ensure the continued health, performance, and reliability of the engine. Never ignore the messages written on your spark plugs. They are speaking directly from the engine's core.